Hey guys, this is Mr. Beckstrom, and today I'm taking a look at another question from section 4.9. This is similar to number 21. This is for the function f given below. Find the antiderivative f that satisfies f of 1 is equal to 1. So what we're going to do is we're going to break this up into three separate antiderivatives, and then we're going to use this additional information here in order to solve for the our constant of integration to c, and then we'll substitute that back in and finish it up from there. All right, so this is really just finding three different antiderivatives, and we're going to use the power rule there for the antiderivatives. And what that's basically, what we do for that is we're going to say when we find the antiderivative of x to some a, that's going to be equal to x to the a plus 1 all over a plus 1. So all we're doing is when we take the antiderivative, we're adding 1 to the exponent, and then we're dividing by that new amount that we get for that exponent. So it's very similar to the power rule, just kind of the opposite for differentiation. For differentiation, we pull it out front and multiply, and we subtract 1 from it. All right. So let's go ahead and do that for each one of these. So let's go ahead and just kind of break it down here. So the f prime of x, that's the first derivative, and we're going to break this into three different ones. So it's the antiderivative of x to the 7th minus the antiderivative of 5x to the minus 2. All right. Plus the antiderivative of 3, like this. All right. So this is going to equal, and then we're going to just use that rule over there. So 7 plus 1 is 8 over 8, like this, minus. And remember the constant, we can just pull that right out to the front. So that's just going to be 5x. Now, negative 2 plus 1 is negative 1, and then we're going to have to divide that by a negative 1 like this, and then plus, and remember, this is really, if you think about it, an x to the 0, right? So if we treat it like that, then this is just 3x to the 1 divided by 1, so that just really becomes what? Just a 3x like this. All right, and we always have to add I forgot to put it over here, a c. Each one of these we should have added a c to, but I can just do it as one c at the very end, because this would be plus c1 plus c2 plus c3, but since they're all arbitrary constants, I can add them together and just put one c at the end. That's kind of a shortcut way to do it. But either way is fine as long as you're showing that we're adding some constant at the end here like that. And I should have put it over here in the formula. Do not forget that constant. It's very easy to forget, as you can see. I just about forgot in the formula there. All right. So now that we've gotten it to this point here, let's clean that up a little bit. We can go ahead and leave that like that. That's fine. Over 8. Those will cancel out there, leaving that a plus, and I can bring that x down to the bottom, so I can just write that as 5 over x, and then just plus 3x plus c. So this is my, I already kind of messed this up here, so that shouldn't have been written like that. That should have been written like capital F, right? Because antiderivative. I'm so used to doing the derivatives, I wrote it like a normal derivative, but this should be a capital capital F as an antiderivative. All right. So we've gotten this far. So now it says the antiderivative satisfies this. That means if we replace our x with 1, then our function value should equal 1. So let's go ahead and do that. I'm going to replace my x with 1. So 1 to the 8th power is 1 over 8 plus 5 over 1 plus 3 times 1. Now go ahead and put that to the 8th power just to, plus c. This should all equal over here 1. And that'll allow me to solve for c. So this is 1/8 plus 5 plus 3. So 1/8 plus 5 plus 3. That's going to be 65 over 8 plus c is equal to 1. And subtract that from both sides, and we're going to get, we'll get c is equal to negative 57 over 8. And therefore, we can replace that c back into this equation right here, and we're pretty much done. So our big F here of x is equal to x to the 8th over 8 plus 5 over x plus 3x minus 57 over 8. And that should be right there. So, so a couple of little tricky things in here. First of all, make sure that you use the big F. I know we're so used to doing derivatives, it's even hard for me to get into the habit of using the big F now to show that we're doing the antiderivative. So let me do a quick thing on this. So if we're going from big to small, it's going to look like this. So you go from big F down to little f, down to single prime like this, and then double prime, and you can just keep going. So if you start here, this would be your first derivative, that would be your second derivative, that would be your third derivative, and then if you're going back, these would be antiderivatives. So kind of use this as your basis. So if you're going from here to here, this would be a 1 antiderivative. If you're going from here to here, this would be 1 antiderivative. If you're going from here to there, that would be 2 antiderivatives. If you're going from here to here, that would be 3 antiderivatives. So this is kind of the order in which it goes there. So hopefully that'll help. And the other thing too is every time we take an antiderivative, we're technically adding some possible constant that we had possibly lost when we had really taken the derivative in the first place. So really we're adding some possible constant every single time we do an antiderivative, but as a shortcut, we can just add a single constant at the very end. That says that we're taking into account all of the possible constants that were lost during the original derivative of the function. All right, if you have any questions, let me know, and have a great rest of your week. Thanks.